Auzu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. Dear students, today our theorem is prove that fx is Lebesgue and integrable if and only if for every pre-assigned epsilon greater than 0 we can find a partition with upper sum capital S and the lower sum small s respectively such that capital S minus s is less than epsilon. This is theorem and also a definition for the Lebesgue integrable function. Proof. Let us suppose that the function fx is Lebesgue integrable. We are to prove that for every epsilon greater than 0 there exists a partition with the upper sum capital S and the lower sum small s respectively such that capital S minus small s is less than epsilon. Since fx is given to be Lebesgue integrable, so by definition I is equal to j because the function is Lebesgue integrable. Since we also know that from the definition that I is equal to LUB of the small s and j is equal to JLB of the capital S, and from the definition of the LUB I must be greater or equal to small s, and the definition of the GLB, J must be less than or equal to capital S for all the partition. Hence, for every pre-assigned epsilon greater than 0, there is some partitions for which I minus epsilon by 2 less than small s and J plus epsilon by 2 must be greater than capital S. Or we can also write capital S is less than J plus epsilon by 2, and if we multiply with minus s is less than minus bracket I minus epsilon by 2. Now capital S minus small s is less than, the value of capital S is j plus epsilon by 2 and the value of minus s is bracket I minus epsilon by 2. Multiplying minus on the bracket, it will become minus I plus epsilon by 2 I minus j bracket plus bracket epsilon by 2 plus epsilon by 2. Epsilon by 2 is equal to epsilon, and we know that j minus I is equal to 0 because I is equal to j or j is equal to I. So capital S minus small s is less than epsilon. That is our direct proof. Now conversely, suppose that for every pre-assigned epsilon greater than 0 there exists a partition with the upper sum capital S and the lower sum small s such that capital S minus small s is less than epsilon. We are to prove that fx is Lebesgue integrable. For this we need to show that I is equal to capital J, where I is equal to LUB of the small s and J is equal to JLB of the capital S. By definition of the JLB, S must be greater or equal to J, and from the definition of LUB, small s must be less than or equal to capital I. If we multiply minus, inequality will change. Minus s is greater or equal to minus I. This implies that capital S minus small s is greater or equal to j minus I, or j minus I is less than or equal to capital S minus small s. But capital S minus small s is less than epsilon, so j minus I is less than or equal to small s minus capital S minus small s is less than epsilon. This implies that j minus I is less than epsilon, but we know that j minus I must be greater or equal to 0, or we can write j minus I is greater or equal to 0 and less than epsilon because it is a positive difference and epsilon is an arbitrary small number. So it means that j minus I is equal to 0. Shifting I towards the right side, j is equal to I. If j is equal to I, this implies that fx is Lebesgue integrable, which is proof. Now we have next theorem. Show that directly from the definition that a function as defined by 1. If x is an irrational in 0 1 close interval and f(x) is equal to 0 if x is an irrational in 0 1 close interval is Lebesgue integrable in 0 1 close interval. B number part. Find the value of the Lebesgue integral. Now the A part is not necessary to prove, but we still remember that this function as defined above is Lebesgue integrable. But we only consider the B number part, which is find its value of the Lebesgue integrable. Since the given function is Lebesgue integrable, then I is equal to j, and the above A number part I is equal to j is equal to 0. So this implies that the integration of the Lebesgue integrable function is 0 1 limit fx dfx is equal to 0 because I is equal to j is equal to 0. Thus the value of the Lebesgue integral is 0.